Welcome to PlanHub's Masterclass courses. My name is Jessica. In this video, you'll learn how to complete a takeoff on a masonry trade using the wall area tool. Knowing how to set yourself up for a successful and efficient takeoff and estimate will save you time and money so you can bid on more projects and grow your company. In preparation for this takeoff, I've reviewed the project files using the file viewer and identified my dumpster layout plan, schedule, and elevation pages. To select a page to begin your work, click on it in the pages list to the left. Our first step is to set our scale. We'll take our measurement from this plan, so we'll use this page to set our scale. Click on the scale tool and align the scale with the scale provided. Now we can start taking measurements to calculate how much CMU we will need for this project. We'll use the wall area tool to perform this measurement. Select the wall area tool. In the properties box, rename your measurement. I recommend naming your measurement after the material install or the type of wall you are installing. You can use the descriptions box to provide additional details. If you already know your average price per square foot for this type of CMU wall build, you can enter that value in here. We'll say $15 per square foot. We'll leave the item type blank as this will cover both our material and our labor. Anytime you use the wall area tool, you need to provide the wall height. This is an 8-foot tall wall, so we'll go ahead and enter in the number 8. Next, we'll define our masonry unit size. Check off the masonry unit option and enter the height and length of your CMU in inches. Click Set to start measuring. To zoom in, roll the wheel on your mouse forward. To zoom out, roll the wheel on your mouse backward. Choose a beginning point on the wall you wish to measure and drop your first point by using a single left click. Now I need to follow the pathway of the wall. Note that this line that is following my cursor is not aligning with the pathway of the wall. This is because the square symbol or the snap to angle tool is turned on. I'll turn this off in my control bar. I'll find the next corner of the pathway of this wall and drop another single left click. Each of these left clicks are equal to a point. Move to the next corner and use the left click on your mouse to drop a point. If you ever wish to undo a point and re-plot that point, use the escape key on your keyboard. Once you reach the end of your wall, you can finish and turn off the measurement by using a double click on your final plot point or a single click, then pressing the Enter key on your keyboard. To the right in my measurements panel, I'm provided with the results of my measurement. The very first number is my total square footage. To expand this information out, to get more details, click on the box with the plus sign. Next, I can see my linear footage for the path that this wall takes and my total units. The details for this CMU wall stated that the reinforcement rebar needs to be installed 16 inches on center. I can utilize the linear footage in my measurements panel to calculate the amount of rebar that I need. However, when I utilize the area tool, it does not account for any additional reinforcement requirements at corners or openings. So I'll need to use the count tool to count those out. Again, I'll name this measurement after the product I'm installing. I can change the color, the pigment level or opacity, the shape, and the size. Click Set once you're happy with the properties. Use your single left click to drop a point in each area that needs an additional rebar. Each corner will require at least 2 additional rebar. At this point, I can send this measurement and its attached values into my project estimate. To do this, check off the items you wish to send to the estimate and click Add to Estimate. Or you can click on the 3 little dots to access the Actions menu for a particular measurement and click Add to Estimate. In the pop-up screen, I'm prompted to select a page in the estimate to send this to, or to create a new page. Make your selection and click Add. Let's take a look at these numbers in the project estimate. Click on the project estimate page at the top. Here I can see that the measurement and its additional measurement details are added to my project estimate as cost items. Note that each of these measurements has the unit cost I assigned when I created the measurement. I can use the actions to edit, duplicate, or delete a cost item. I can also perform bulk actions by checking off the cost items and using the Actions menu at the top. In the Actions menu, I can add these cost items to a group, save these cost items to my cost item library, duplicate these items, make adjustments. When making adjustments, I have the option to adjust the unit via waste, the rate of my unit cost, the unit quantity, and the overhead and profit. I can also remove items from the estimate, exclude them from totals, or include them from totals. If you're a subcontractor who already knows your average cost per square foot for a CMU wall build, this approach can be very efficient. However, due to various sizes, project-specific build requirements, and changes in material cost, sometimes this approach is just not enough. If you need a more detailed bill of materials and cost breakdown, we can use the assemblies. An assembly uses each of these numbers in a formula to help me calculate the materials that will be required to build this wall and the cost of those materials. To get to the assemblies, click on the Assemblies tab in your Takeoff tool. The Assemblies page has a list of all assemblies you and your team have created and saved. Each assembly has an owner. This is the user that created the assembly. If you have multiple users, only the owner of the assembly can edit or delete the assembly. Users on your account who are not the owner of an assembly can utilize or duplicate an assembly. This means that you can build out a library of assemblies as a team. If you or your team have not created any assemblies, you will see a list of assembly examples. These examples do not have a unit price or formula attached to the line items. You can use the search bar to search for an assembly by name. To create a new assembly from scratch, click Create Assembly. When creating or editing an assembly, you have 2 areas: the Assembly Creation area and the Cost Item Library area. All assemblies must have an assigned name. I recommend naming the assembly after the product you have listed in the assembly or the type of install you're performing. I'll name this one 8-inch CMU dumpster number 4 rebar. Next, I need to select which of the measurement tools this assembly will be available for. Because this is a CMU wall that I measure using the wall area tool in Takeoff, I'll select the wall option. Moving forward, this assembly will be available as an option for all my wall area measurements when I select to send it into an assembly. All other fields in the assembly title are optional. Next, we need to start adding our cost items. You can use your library of saved cost items to help you build an assembly. Because I've already created some CMU items in my cost item library, I can search them out using my search bar. Enter the name of the cost item in the search bar and click the search icon. Then to add this cost item to your assembly, check off the item or items you wish to add and click Add. To remove an item from your assembly, check it off in your assembly list to the right and click Remove. You may wish to create a cost item from scratch. To do this, click Add New Cost Item. When creating a from scratch cost item, note that all fields with a red star or asterisk are required. Give your item a name and then give it a description. In the description field, I like to either include how I purchased this item or what I want my output to be. I want to know how many blocks I need to purchase, so I am putting by the block. The more fields that you are able to fill out for each individual cost item, the less editing you will need to do once this item has been pushed through an assembly into an estimate. Each of these items will need to have some slight updates made to them so that I can account for my waste and how I purchase them. To edit them, click on the edit symbol. When editing your line items, you can choose to edit them by the item, kind of like you're reading a book, filling out all fields that apply, and then moving on to the next item in the list. Or you can choose to approach each item by the column. I like to take the column approach. Just make sure, whichever approach you take, that you save your changes when you're done. We'll start with our waste percentage. For CMU count, I expect to experience about a 10% waste. For my labor for CMU, I don't charge my customers a waste on my labor, so I'm going to leave that at 0. Next is the type N mortar. We'll account for about, again, another 10% waste. We'll do 10% on the rebar. For our wire ties, we'll say about 5%. And then for the cap blocks, we'll do 10%. Next, we'll fill out the unit cost column. Because the first 5 items came from my library, I don't need to fill out the unit cost for these unless I wish to bill for these differently. However, for this last one that I'm creating from scratch, I will need to enter in my unit cost. Next, I'll enter in the tax rate for each of these line items. Then I'll select my item types for any of the missing fields. Finally, we have our unit of measure. Your unit of measure should reflect what you want the system to tell you. For example, if you want to know how many 80-pound bags of mortar you will need, you'll want to select the option closest to bags. Click into the box and scroll through to see all of the options available. Select the option that best aligns with what you want the system to tell you. Please note, your unit cost and your unit measure should align. I'll need to adjust the price for my wire ties because this is by the 400-foot roll. Now let's stop and talk about how we prepare for our formula and how our unit cost and our unit of measure ties into that. Formulas are how we manipulate a unit. Each line item's formula can only provide you with one output type. This means if I want to know how many blocks I need, my formula, my price, and my unit of measure should be a reflection of that. So as we're getting ready to prepare and build formulas, we need to keep in mind our unit price and our unit of measure. Now let's save our changes and start building out our formulas. Click the F of X symbol to build and assign the formula for this line item. In the formula box, you will have your formula building area and your library area. Once you save a formula, it will be added to your library and you can use it on future assembly items instead of rebuilding it each time. In the library area, you also have custom variables. These really come in handy when you want to assign a name to a variable that is not already an option in our simple variables provided to the left. Custom variables help make your assemblies easier for multiple users to utilize that assembly. For our CMU formula, we'll first give it a name. CMU units. For the description, we'll add by the block. Next, we'll use the custom variables to create a unique variable to enter in the number of blocks our measurement provides us with. Select Custom Variables and click Create New. Enter in your variable name. Click Save, and then click the plus sign for that variable. Note that it has been added to our formula box to the left. No other math is required for this particular line item, so now we can save and apply it to the cost item. Next is our labor. Select the f of x for that line item. Name your formula. Because we bill per the square foot, the formula for this is very straightforward. We just need the square footage of the surface of the wall. We'll use the area option in our simple variables. No other math is required, so we'll click Save and Apply to Cost Item. Next is our 80-pound bag of Type N mortar mix. We'll give our cost item a name. Now, this one will be a bit more complicated. An 80-pound bag of Type N mortar mix will typically cover enough to lay around 12 to 15 standard 8-inch concrete masonry units with a 3/8-inch mortar joint. Coverage can depend on joint thickness, any waste factors you've added in, and specific. Because I can calculate this by the number of blocks, I'm going to add that detail into the formula name. Next, we're going to use our custom variable for the CMU. And if one bag covers about 12 to 15, we'll split the difference and we'll go ahead and say a bag covers on average about 13 blocks. So I'll take my CMU and divide that by 13. The output of this would be how many bags I need to build a wall. For example, if I go ahead and test this formula and I have 130 blocks and I click Run, I should expect to need 10 80-pound bags of Type N mortar mix. If I'm happy with this result, I'll go ahead and click Save and Apply to Cost Item. For the rebar, this is installed at the top and bottom horizontally along the length of the wall, plus it's installed vertically every 16 inches on center. So I'll go ahead and get started on that formula, and I'll use those details when I build the formula. My formula name will be number 4, rebar, CMU, dumpster, and then those variables, top and bottom layers plus 16-inch on center verticals. Next, let's start building the formula. If we are installing one layer horizontally on the top and the bottom of this wall, I'll need to take the length and multiply it by the number of layers we're installing. So I'll use my simple variable length, multiply, and then I'm going to use one of my custom variables for the number of layers, because sometimes when I build this, it may require more layers. And I do want to be able to enter this value in according to the project and the wall that I'm building. So we'll grab that. Next, we need to account for the vertical rebar that is 16 inches on center. For that, we will take the length again and divide that by 1 foot 4 inches, which is 16 inches in total. That will tell us how many vertical pieces of 8-foot rebar we will need to install. Then we will take this number, the number of vertical rebar, and then multiply it by the height of the wall. Note that my syntax is invalid. To correct this, I'm adding parentheses to these equations. Equations inside of a parentheses is solved first and individually, followed by solving for exponents outside of a parentheses, such as our plus sign, adding these two equations together. These two equations added together equal the total linear foot of rebar that I will need. Now we need to convert this from linear feet to pounds. We'll take our total linear footage output and multiply it by the weight of our rebar per foot. Now, number 4 rebar is about 0.66 pounds per linear foot. When utilizing decimals that are less than 1 in PlanHub, be sure to add the 0 in front of your decimal. To test the formula, click Test Formula and fill in the variables with common, easy-to-check numbers. Click Run, and your result will be provided below. If this is the expected result, click Save and Apply to Cost Item. If you do not want to see any decimals in your output and you always want it to be rounded up to the next whole number, be sure to check off Roundup Results. I want to see the decimal, so I will leave that unchecked. Save and Apply to Cost Item. Next is our rebar tie wire. As we enter into the formula for this, let's remember that we want to know how many 400-foot rolls we will need. Our formula should be based on this. We will use about 6 inches per point that the rebar overlaps with another piece of rebar. In this particular build, for every vertical piece of rebar, we will need to use 2 6-inch lengths of tie wire, one at the top and one at the bottom. As a result, we will need to use some of the same type of equations we used in our previous formula. Rather than rebuilding this, I'm going to add it and then make adjustments and save it as a new formula. Remember to name your formula after the purpose of the formula. A couple changes will be needed. We don't need to know our weight, so we'll remove that. The height does not impact the tie wire, so we'll remove that as well. But for every point where rebar crosses another piece of rebar, meaning the top and bottom of each vertical rebar crossing the horizontal rebar, we will use 6 inches of rebar tie wire. So I'll just need this equation telling me how many vertical points I have multiplied by the number of layers, which is my rebar cross points. From there, I will take that value, multiply it by my 6-inch length of tie wire. That'll tell me how many feet I will need of tie wire, and I will take that entire value and divide it by how many feet I get per roll. Now let's test our formula. Again, we're going to use numbers that are easy to check. As you can see, I am provided with a decimal because I purchased my tie wire by the 400-foot roll. Now, if I know that I'm going to be performing CMU on many, many different areas within the same project, I may wish to keep this in a rolls format. However, if I wish to switch this over to a linear footage format, I can pull that division by 400 out, but that means that I'll also need to make sure that I'm updating my unit of measure and my cost per item inside of the line item in that assembly. I'll keep this at my 400-foot roll format. I'm going to click Save as New so we don't overwrite our previous formula, and then click Apply to Cost Item. Finally, we have our cap blocks. These are installed along the top of the wall in a single layer. These cap blocks are 16 inches long, so the number of cap blocks that I need will be the length of the wall divided by 16 inches. Make sure you name your formula. And then we're going to use our simple variables. Length divided by 1 foot, 4 inches, will equal the number of blocks required to run along the length of this wall. Click Save and Apply to Cost Item. Now we have added our cost items and created our formulas for each of the items in order to build this particular wall. Let's go ahead and save our changes so that we don't lose the work that we've performed, and see what this looks like inside of the assemblies page. You can see the assemblies I created in the list. To expand and view all cost items included this assembly, click on the gray arrow to the right. If you have created any cost items from scratch as part of this assembly creation, and you wish to save those cost items to your cost item library for future utilization, click on the Save to Cost Item Library icon. Now let's go use this assembly with a measurement and push it into our estimate. To do so, navigate back to your Takeoff page by clicking on the project name in your navigation bar. Find the wall area measurement you wish to use this assembly on in your measurements panel over to the right. Click on the box with the plus sign inside of it to expand this measurement's details. You'll need to click on the next box as well to get the full detail list. We will need this information based on the formulas we created for this measurement. To send this measurement through an assembly and into the estimate, click on the three little dots next to the measurement or right-click on the measurement. In the drop-down menu, click on Send to Assembly. In the pop-up window, you'll be provided with a list of all assemblies that you have created for wall area measurements. Find the assembly you wish to use and select it. Next, select the page in your estimate that you wish to send this measurement into. You can choose to create a new estimate page or send to an existing page you have already created. Then click Add. Next, you will see a window with a number of fields with values attached. These are directly associated with the formulas that you created. As you can see, the custom variables we created with their names are provided. My 8x12 MUs value is equal to my CMU count provided over here to the left. I'll enter this value into this field. Note that when I entered it into this field automatically populated. If you do not wish the system to automatically populate all repeating variables, toggle this tool off. This way you can make a change to one field and make a change to the next field as needed. When turned on, any edits will impact all repeating variables. Next, we'll enter in the number of layers of rebar. Finally, we'll click Insert Value. Note that you'll receive a confirmation that the assembly has been added to the selected estimate. There is a hyperlink provided in this pop-up so that you can open your estimate in a new tab. Here we can see our assembly. Note that assembly line items are a different color and have the ability to be expanded. Once expanded, you can see the broken down details of your material need and cost if you have calculated for both in your assembly. Additionally, you can see our waste calculation and our local tax rate applied to our line items. If you wish to make additional adjustments to your rates, please feel free to utilize the Adjust Rates or Overhead and Profit tools. I hope you log into your PlanHub account and use what you learned today to build your estimates and bid more projects. Thank you for watching.